Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 7-1 on ratios and proportions. Here's some of the vocabulary and important ideas you need to cover today, and this should all be in your notes. We're going to cover ratios, which is just a comparison of two quantities. So if I wanted to compare your age to my age, let's say you were 16 years old, I could write this a couple of different ways as a ratio. I could, say that you're 16 years to my 42 years. I could also write this as 16 is to 42 with a colon, and the way that you've usually seen it is as a fraction. 16 to 42. But these are all ratios and just different ways to write them. Now, a proportion is a statement that says that two ratios are equal. So here's our ratio from the last page, and if we wanted to, we could reduce this ratio by 2's, and the 16 divided by 2 would be 8, and the 42 divided by 2 would be 21. And this is now a proportion because I have one ratio equal to another ratio. You might see something called an extended proportion, which is when 3 or more ratios are all equal to each other. So this is from our proportion page, and if we wanted to extend this proportion, we could multiply each of the numerators and denominators by any number, let's say 3 in this case, and we would make this 24 over 63. And now we have an extended proportion because we have 3 ratios that are equal to each other. The properties of proportions are what we're going to talk about next, and the most important property is called the cross product property. So if you have a proportion, one ratio equal to another ratio, the cross product property says that if you multiply the information that's across from each other, like an x, you'll be able to get another equation. So what you end up with is a times d is equal to b times c. You see this in your homework here in the yellow. 5 over z equals 20 over 3, and they ask you to solve for the variable. So to do that, you're going to use the cross product property here, and you're going to end up with 5 times 3, which is 15, equals 20 times z, which is 20z. And then to solve this, you would divide both sides by 20, and then you reduce 15 over 20, and you get 3 over 4 equals z. So the cross product property is the most important property of proportions. Some of the other ones, the cross product property is also called the means extremes property. And then the most important thing to remember about properties of proportions is that you need to be consistent. So for example, we're going to start here with a over b equals c over d. And there are different ways that you can manipulate those two fractions that still make it equivalent. So for example, we can take the reciprocal of a over b and turn that into b over a, and then we have to take the reciprocal of the right-hand side as well, and c over d becomes d over c, and that's one property. Another property is to take the a and the c, the numerators, and turn them into their own fraction, a over c, and take the denominators b and d and turn them into a fraction as well, b over d. Again, you just have to remember to be consistent. So if you're going to start with the left-hand side on the top, you have to start with the left-hand side on the bottom. And then the last property down here, notice they take the denominator and move it up to the numerator in order to add the denominator, and they do that to both sides. So a plus the denominator b over b equals c plus the denominator d over d. All right, our last vocab is a scale drawing or a scale, which compares a length in a model to the actual length, and it can use different units. You might have 1 inch is the same as 100 miles or whatever like that. Here's an architectural scale model. So they have brought everything down to scale. So it's the same size as it would be if it was real. It's just in a much smaller version so that you can see the overall picture. This problem comes from your practice, It says a photo that is 8 inches wide and 5 1/3 inches high is enlarged to a poster that is 2 feet wide and 1 1/3 feet high. What is the ratio of the height of the photo to the height of the poster? So we make a ratio, which is just a fraction. We put the height of the photo on the top, which is 5 1/3, over the height of the poster on the bottom, which is 1 1/3. Remember that the photo is in inches and the poster is in feet, so we will need to convert one of them into the other. So I converted the 1 1/3 feet into 16 inches. To get rid of the 1/3 fraction there, you can, instead of dividing by 3, you can multiply everything by 3. And you get 16 over 48, which can then be reduced by 2s, 4s, 8s, or by 16s to get 1 over 3. So our answer is 1 to 3. And our last one for today, you want to make a new map with a scale of 1 inch to every 35 miles. Two cities that are actually 175 miles apart are to be represented on your map. What would be the distance in inches between the cities on the new map? So we can do a proportion, we just have to remember to be consistent. So if you want to put 1 inch for every 35 miles as one of your ratios, we want to set it equal to the ratio that's in real life. And we have to have miles on the bottom of our map scale, so we would need to keep miles on the bottom of our real life. And our answer is how many inches, and that's X inches for now. Then we can cross product property this to get 35X equals 1 times 175. And then you can divide both sides by 35, and you will get X equals 5. The answer is 5 inches. Good luck, everybody. I hope you guys all do great.